Hey everyone, in this video we are going to take a look at 4.2 and simple linear regression and perform some of these calculations using Excel. So what we have in this table that I began to create right here, these two columns, they are the data from a construction company. So column A is the sales data, and that happens to be in hundreds of thousands of dollars. And column B happens to be the local payroll, which is in hundreds of millions of dollars. So what happens is we want to predict what are the sales going to be given a specific amount of payroll. So to begin with, I want to look at this blue graph over here. What you can see here is these black dots. These black dots are our data points. They are a value, y value of 6, x value of 3. We can see you can go up 6 over 3 or to the right 3 up 6. That gives you your first data point. Then we have all of our other points in there as well, but then there's this blue line in here. This blue line helps us to project future information. So if I were given an amount of payroll in the future, then what would my sales, what can I predict or project or forecast my sales to be? So with this blue line, we want to get that blue line in there perfectly so that we minimize the error. And the error is the space between our points, our little black dots that we have, and the blue line. If we add that all up, and remember typically we add up and look at the square value because it's easy to see how if I add something above the line and something below the line, they would cancel out. But essentially, again, we need to place this line perfectly so that we minimize the space between the dots and the straight line. With that said, if we have sample data like we do here, we want to look at this equation, y hat equals b naught plus b1 times x. So we can use the data that we have to calculate b naught and b1, which in turn will give us the equation for this blue line. Y hat is the blue line, or b naught plus b1 times x is the blue line. For some of you that may remember some things from math a while back, this is our slope-intercept form. The slope is the b1, the intercept is the b naught. So below this equation, we have the equation for b sub 1 and the equation for b naught. Now b sub 1 is the sum of the quantity x minus x bar times the quantity y minus y bar, the sum of all that. Sums are pretty simple to do in Excel. That's why we're using Excel. Divided by our denominator is the sum of the quantity x minus x bar squared. So the bar above our coefficients here signifies that it's the average. And there are a few different ways that we can do average using Excel, so we're going to take a look at both of those. Then over to our b naught equation, or our intercept, our y-intercept, b naught is equal to y bar, which is the average of y, minus b1 times x bar. Again, x bar is the average of our x data, our column B, or all the data here, which was payroll. Okay, so let's begin by performing our calculations. I'm going to put some solutions down here in these cells. So what's nice to do is to put a line right above that or right below my calculations that I programmed into Excel. So I'm going to highlight these 4 cells and then go up to the top right under this font drop down menu. We can see this little icon, and it has a dotted couple of squares and a line at the bottom. Well, you can click on that and see all the possible borders. I don't know what I just clicked on that you can put in here. I want a bottom border. So if I go back, I can see I put a bottom border in there. Let me make these white again, and it'll be easier to see that line. Okay, so, and what happened, I made those white. I actually want no fill. That way I can see those gray squares as well. Okay, so I'm going to try to include a couple tips and tricks for Excel that maybe you haven't seen in a while or you've never seen before. All right, so if I look at my first equation, x minus x bar squared. Well, I have an x value. I don't have an x bar value, so we need to calculate that. And just real quick, if I glance over at my next equation, I'm going to need y bar, or the average of y, also. So I said we would do this two different ways. The first way we will look at our y data, what we want to do with average is you add everything up and divide by the number that you have. So the sum of all of these numbers divided by, we have 1, 2, 3, 4, 5, 6 numbers, divided by 6. So the average, or y bar, is equal to 7. I'm going to go ahead and I'm going to write y bar under that, just so that we can remember what it was. You can take the time to make your Excel spreadsheet a little bit fancier too if you like. Okay, the other way that I can do that is to use the average function in Excel. So equals average, you have to type out the whole word and open parentheses, select everything you want, close parentheses, equals. So the average here is 4, the average of our x data. Okay, now for our heavy calculations. Always start them out with an equals. So equals, open parenthesis, x minus x bar, that was our 4, close parenthesis, squared. Okay, just bear with me for a second. I'm going to push equals, then I'm going to drag this down. But what happened? Why did I get super crazy stuff here and this pound value thing going on here? Well, if I click on any of these, I can see that I'm no longer including the 4. My cells went down as I drug my formula down. That means I need to lock it in. I always want it to be that 4, but I don't want to type in 4, because if I should change one of my payroll numbers, then that change is not going to be reflected. So I fixed that, locked it in, drag those down. Now, what do we need though for our calculations? Look down with me, and I actually want the sum of all of those. I want the sum of the x minus x bar squared. And to get that, just using Excel, we want equals the sum of all that data, which is 10. And I put this in the wrong spot, so I'm going to just click Control X to cut it, Control V to paste it up there. And again, I like it centered. You can go ahead, drag on all that, and center it. X minus x bar times y minus y bar. So again, equals x minus x bar. Careful, don't grab your column C because that was squared. So we need our x value minus x bar, lock that in, times y minus y bar. Again, lock it in. You need a $ in front of both the A and the 8 because you're locking in the row and the column. Close parentheses, equals. It's telling me I have a typo. If I look or compare, I can see they've included the multiplication symbol between my two sets of parentheses. Yes, I want to accept this correction. So hit enter and we're good to go. Now I can click on the corner, drag all that down. Again, I like it centered. You can leave it how you would like it. Now looking down at my calculations, again for that B1 calculation, we need the sum of all that. So equals sum of all those numbers, forgot to center that one, close parentheses, enter. And I lost my line there. It's easy to go back and put that in. Okay, so what was this? This was x minus sum x minus x bar times y minus y bar. And again, you can get fancy, you can enter in the calculations if you like. Now we need to take these numbers, perform these calculations in the black box, and find our actual equation of that line. So B1, I'm going to calculate it just over here. I can make this cell yellow so you can follow along. So this is going to equal this sum of x minus x bar times y minus y bar, or that 12.5, divided by 10, the sum of x minus x bar squared. That is B1. Now, notice something with me. I put an equal sign here. I wanted it to actually show that equal sign. So in front of it, I put apostrophe. If you lead with an apostrophe, it's actually going to display whatever you type in there. That's very handy, especially when you're typing numbers and stuff, because Excel likes to default to putting it to dates. Okay, now I need to calculate this B naught. So B naught equals Y bar minus B sub 1 minus X bar. Or equals, so Y bar, the 7, minus B1, or 1.25, times 4, our X bar, or 2. Okay, so remember back to algebra with me real quick. Maybe it's been a while. But B naught is our y-intercept. So if I look up at that graph, I am intersecting the y-axis at 2. So that matches up. And this 1.25 is my slope. So slope, remember, is rise over run. So for every 1 I go up, I go to the right 1.25. So now my equation for this actual line is y hat is equal to B naught, or the 2, plus 1.25 x. So if I am given a payroll value prediction for the future, I would take that and plug it in for my x and calculate out this y hat value, and that is my prediction for the sales that we will use whatever year the payroll is from. So go ahead and skim through this in the book too. This one I know was a little bit clunky, but as you get the hang of these, using Excel will make things a lot easier for you. So let me know if you have any questions, and have a great day.